Hello there. Tonight, we'll drift gently through the hidden chambers of your mind, where memories live in shadows you cannot see. The subconscious holds more of your life than you might imagine, storing feelings, skills, and moments in ways that consciousness never touches. Welcome to Get Sleepy Science. I'm so glad you found your way here tonight. Wherever you are right now, perhaps lying in bed with the lights dimmed low, or maybe with the gentle hum of the world settling into quietness outside your window, allow yourself to settle into this shared moment of stillness. We'll explore 100 remarkable truths about the subconscious mind and memory, from the hidden networks that activate when you rest, to the ancient structures deep in your brain that decide what to keep and what to let fade, to the mysterious ways your sleeping brain reshapes what you've learned during the day. If these thoughtful journeys through the mind help you slow down, a soft like helps more curious minds drift this way. It only takes a moment, but it means the world to us, one sleepy soul at a time. For now, just let your shoulders soften, let your breathing fall into its own rhythm. You don't need to remember everything tonight. You don't need to understand everything perfectly. Imagine yourself drifting in a space of gentle curiosity, where facts become stories and stories become dreams. Close your eyes and take a deep breath. You're part of an endless stream of consciousness, where thoughts bloom and dissolve like waves, moving without boundaries, without destination. Let go of all limits. Let your mind drift through the space of awareness. Your brain never truly rests. Even when you're sleeping or sitting quietly, a vast network of brain regions continues its ceaseless activity. Neuroscientists call this the default mode network, and it was only discovered in the early 2000s when researchers noticed something curious. The brain regions that became most active during rest were the same ones involved in remembering the past, imagining the future, and thinking about yourself and others. The default mode network includes areas like the posterior cingulate cortex, the medial prefrontal cortex, and the precuneus, all working together in synchronized harmony. Recent research from 2025 confirms that this network serves as the core of consciousness itself, constantly creating your internal narrative and sense of self. When you daydream, when you let your mind wander, when you're simply existing without focusing on any particular task, this hidden network is orchestrating the silent theater of your inner world. Your subconscious is never truly silent. The subconscious mind processes information far faster than conscious thought. Studies using functional brain imaging show that your brain often makes decisions 7 to 10 seconds before you become consciously aware of having decided anything. In classic experiments updated through 2025, researchers can predict which button a person will press based solely on brain activity patterns detected seconds before the person feels they've made a choice. This suggests that much of what you experience as deliberate choice emerges from deeper processing that happens beneath awareness. Your conscious thoughts are shaped by subconscious currents you cannot see. The vast bulk of mental activity occurs in hidden depths where feelings, memories, and patterns work silently. The subconscious is the unseen architect of your decisions. Memory is not stored in a single place in your brain. Unlike a computer that saves files in specific locations, your memories are distributed across multiple brain regions, each storing different aspects of the same experience. When you remember a childhood birthday party, one area might hold the visual image of the cake, another the sound of laughter, another the feeling of happiness. The hippocampus, a seahorse-shaped structure deep in your brain, acts as the organizer, binding these scattered pieces together into a coherent memory. Recent research from 2025 shows that during sleep, the hippocampus replays memory fragments in conversation with the outer layers of your brain, gradually transferring memories from temporary to long-term storage. Your memories live everywhere and nowhere at once. Not all memories reach conscious awareness. Scientists distinguish between explicit memory, which you can consciously recall, and implicit memory, which operates entirely beneath awareness. Explicit memories include facts you've learned and personal experiences you can describe, like what you had for breakfast or the plot of a movie you watched. Implicit memories include skills you've practiced until they become automatic, like riding a bicycle or typing on a keyboard without looking. They also include emotional associations and conditioned responses you may not even realize you've learned. The amygdala, an almond-shaped structure involved in processing emotions, creates powerful implicit memories about threatening or rewarding situations. These memories can influence your behavior and feelings without you ever consciously remembering the original experience. You carry wisdom your conscious mind cannot access. Sleep is essential for memory consolidation. During deep, slow-wave sleep, your brain replays the day's experiences in a sped-up manner, strengthening the neural connections that encode those memories. Research published in 2025 using advanced brain stimulation techniques shows that enhancing the coordination between slow brain waves and sharp bursts of activity called ripples can improve memory performance. Scientists at major research institutions demonstrated that precisely timed stimulation during sleep enhanced both the electrical coupling between brain regions and people's ability to remember information the next day. Without sleep, memories remain fragile and easily forgotten. With sleep, they become woven into the enduring fabric of your mind. Each night, your subconscious silently cements what matters, letting trivial details fade into the darkness like morning mist dissolving in sunlight. The hippocampus is crucial even for types of memory once thought not to need it. Traditional memory research divided memories into hippocampus-dependent, like spatial memories and personal experiences, and non-hippocampus-dependent, like simple recognition of objects. Recent studies from 2025 challenge this division. Researchers found that when rats were allowed to sleep after learning, even simple object recognition memories, previously considered independent of the hippocampus, benefited from hippocampal activity during sleep. The hippocampus appears to process and stabilize a wider range of memories during offline states than previously understood. This finding suggests the sleeping brain employs the hippocampus as a central hub for organizing many kinds of information, not just spatial or episodic memories. Sleep transforms what you've experienced into something more permanent, and the hippocampus orchestrates much of this transformation in the hidden hours of darkness. Your earliest childhood memories are stored differently than later ones. Infants and very young children form memories, but these memories rarely become the explicit, narrative memories you can consciously recall in adulthood. This phenomenon is called infantile amnesia. The hippocampus, essential for forming explicit long-term memories, is immature during the first 2 years of life. Memories encoded during this period tend to take the form of implicit knowledge, habits, and emotional associations rather than specific, recallable events. Research from 2025 emphasizes that early experiences still shape who you become, but they live in your subconscious as feelings and tendencies rather than as stories you can tell. The earliest foundation of your sense of self exists in a realm beyond words, beyond conscious memory, woven into the very structure of how you relate to the world. Emotional memories are more vivid and persistent than neutral ones. When something emotionally significant happens, whether joyful or distressing, your amygdala becomes highly active, releasing stress hormones like cortisol and activating neurotransmitter systems involving norepinephrine. These chemical signals enhance memory encoding in the hippocampus and surrounding brain regions. Recent 2025 research shows that the amygdala's response during the first encounter with an emotional event predicts how well you'll remember it later. Importantly, this enhancement occurs through increased stability of neural patterns when you encounter the same emotional stimulus again. Your brain essentially creates a more precise template for emotional memories, making them easier to retrieve. However, while emotional memories feel more vivid and detailed, they are not necessarily more accurate. The confidence you feel when remembering emotional events can sometimes exceed the actual accuracy of those memories. Fear conditioning demonstrates how powerfully the subconscious learns. In laboratory settings, researchers pair a neutral stimulus, like a tone, with something unpleasant. After just 1 or 2 pairings, the tone alone elicits a fear response, measurable through changes in heart rate, breathing, and skin conductance. Remarkably, this fear conditioning occurs even when the tone is presented too briefly for conscious awareness, a technique called masking. The person never consciously sees or hears the conditioned stimulus, yet their body responds with fear anyway. This demonstrates that the amygdala can learn and trigger emotional responses entirely outside conscious awareness. These implicit fear memories can persist for years, influencing behavior and emotional responses in ways you might not understand. Understanding this mechanism helps explain why certain situations trigger anxiety or discomfort, without any conscious memory of why. During REM sleep, when most dreaming occurs, the brain processes memories differently than during slow-wave sleep. Slow-wave sleep, characterized by large, synchronized brain waves, particularly benefits hippocampus-dependent declarative memories, those you can consciously recall. REM sleep, with its rapid eye movements and more wake-like brain activity, appears to benefit procedural memories, the skills and habits that operate beneath conscious awareness, as well as emotional aspects of memory. Studies show that the balance between early night sleep, rich in slow waves, and late night sleep, rich in REM, contributes to different aspects of memory consolidation. The stress hormone cortisol, which is low during early sleep and rises during late sleep, also influences which types of memories get strengthened. Your sleeping brain carefully orchestrates this complex dance, deciding what to keep, what to integrate, and what to let dissolve. The prefrontal cortex, the front part of your brain behind your forehead, helps regulate emotional memories stored in the amygdala. This region is involved in reasoning, decision-making, and cognitive control. When you consciously reappraise an emotional situation, thinking about it in a new way or from a different perspective, your prefrontal cortex modulates the amygdala's activity, potentially reducing the emotional intensity of the memory. Research from 2025 examining people with anxiety shows that weaker connectivity between the prefrontal cortex and amygdala is associated with stronger implicit memory biases toward negative information. This means that when the regulatory connection weakens, the subconscious becomes more prone to automatically noticing and remembering things that trigger worry or fear. Strengthening this connection through practices like mindfulness or therapy may help restore balance between conscious reflection and automatic emotional responses. Memory retrieval is not like playing back a recording. Each time you remember something, you reconstruct it from fragments, and in the process, the memory can change. This is called reconsolidation. When you retrieve a memory, it temporarily becomes unstable, open to modification before being stored again. Current research shows that memories are not simply pulled from storage intact, but are actively rebuilt each time, incorporating present feelings, knowledge, and expectations. This means your memories are living, evolving records rather than fixed archives. A memory of a childhood event might be colored by emotions you feel now, or details might shift to fit your current understanding of the world. Your subconscious continuously rewrites your past, not to deceive you, but because memory serves the present more than it preserves the past. The subconscious can hold knowledge you don't consciously know you have. This is demonstrated through priming effects, where exposure to one stimulus influences response to another without awareness. For example, if you're briefly shown the word bread too quickly to consciously register, you'll respond faster to the related word butter moments later. Your subconscious registered and processed the first word even though it never entered conscious awareness. Similarly, people often perform better than chance on recognition tests for information they insist they never learned, a phenomenon called implicit learning. Your brain absorbs patterns, associations, and information from your environment continuously, building a vast library of implicit knowledge that guides behavior, preferences, and intuitions. Much of what you know resides in shadows you cannot directly illuminate. Different types of memory depend on different brain systems. Semantic memory, your knowledge of facts and concepts, relies heavily on lateral and ventral regions of the temporal lobe. Episodic memory, your recollection of personal experiences situated in time and place, depends on the hippocampus and surrounding structures. Procedural memory, your knowledge of how to perform skills, involves the basal ganglia and cerebellum. Working memory, the ability to hold information in mind temporarily while using it, engages the prefrontal cortex. Most people can hold roughly 3 to 5 items in working memory at once, though this varies with practice and the type of information. Each system can operate somewhat independently. Someone with hippocampal damage might lose the ability to form new episodic memories but still learn new motor skills. Your mind is not a single unified system, but a society of specialized processes, many operating beneath the surface of awareness. Forgetting is not always a failure of memory. In many cases, forgetting is an adaptive process that prevents your mind from being overwhelmed by irrelevant details. The brain appears to have active mechanisms for weakening or eliminating memories that are no longer useful. Recent research suggests that during sleep, Some memories are strengthened while others are actively weakened, a process that helps maintain cognitive efficiency. Your subconscious acts as a curator, deciding which experiences deserve long-term storage and which can safely fade. This selective forgetting allows important patterns and knowledge to stand out more clearly. Sometimes the things you forget are the things that no longer serve you, quietly released by a deeper wisdom than conscious choice. Your mind knows what to keep and what to let go, operating with a logic beyond awareness. Implicit biases, those automatic attitudes and stereotypes that affect understanding and behavior, are stored in the subconscious. They develop through exposure to cultural messages, media, and social environments, often without conscious awareness or endorsement. Research from 2025 examining implicit emotional memory shows that these automatic associations, particularly negative ones, are mediated by connectivity between the amygdala and other emotional processing regions. Stress hormones like cortisol and neurotransmitters like norepinephrine influence how strongly these implicit associations form and persist. Importantly, implicit biases can exist even in people who consciously reject those attitudes. The subconscious absorbs patterns from the environment automatically, and changing these deeply embedded associations requires sustained conscious effort and exposure to counterexamples. Awareness of your implicit biases is the first step toward gradually reshaping the hidden architecture of automatic thought. The phenomenon of déjà vu may arise from a temporary glitch in memory processing. This strange feeling that you've experienced the current moment before, despite knowing you haven't, might occur when sensory information reaches memory systems slightly out of sync. One theory suggests that déjà vu happens when the brain's recognition system activates before the conscious perception system fully processes the experience, creating a false sense of familiarity. Another theory proposes that a current experience closely resembles a past one, in subtle ways your conscious mind doesn't notice, but your subconscious detects the similarity and generates the eerie feeling of recognition. Though still not fully understood, déjà vu reminds us that the relationship between conscious experience and subconscious processing is complex, fluid, and occasionally produces fascinating anomalies. The mind's machinery sometimes reveals itself through these brief, strange moments. Expertise involves transferring knowledge from conscious to subconscious control. When you first learn a complex skill like playing an instrument or speaking a new language, every action requires focused, conscious attention. With practice, the movements and patterns become automatic, controlled by implicit procedural memory systems. This transition frees your conscious mind to focus on higher-level aspects of performance. A skilled pianist no longer consciously thinks about which fingers to move, allowing full attention to emotion and interpretation. Research shows that once a skill becomes automatic, trying to consciously control it again can actually impair performance, a phenomenon called overthinking. Your subconscious, when properly trained, can execute complex sequences with a fluidity and precision that conscious control struggles to match. Mastery means trusting the hidden layers of your mind. Sleep deprivation severely impairs memory formation and retrieval. Without adequate sleep, the hippocampus cannot effectively encode new memories, and the replay processes that consolidate memories during sleep simply don't occur. Studies show that even one night of poor sleep can reduce memory performance significantly. Chronic sleep deprivation leads to cumulative cognitive deficits that affect learning, decision-making, and emotional regulation. Recent research from 2025 emphasizes that the interaction between sleep stages, particularly the coordination of slow waves, spindles, and hippocampal ripples, is essential for optimal memory consolidation. When you sacrifice sleep, you sacrifice your brain's ability to process experiences, organize thoughts, and prepare for the future. The subconscious requires darkness, stillness, and time to perform its essential work. Rest is not laziness but necessity. Context influences memory retrieval powerfully. You remember information better when you're in the same environment where you learned it, a phenomenon called context-dependent memory. This is why returning to your childhood home can trigger a flood of memories you hadn't thought about in years. The sights, smells, and sounds associated with the original experience serve as retrieval cues, helping your subconscious locate and reconstruct the memory. Even internal states matter. Information learned while happy is more easily recalled when happy again, and the same applies to other emotional states. This context dependency explains why memories can seem to hide until the right trigger appears. Your subconscious stores memories not in isolation but embedded within a rich web of associated sensory and emotional information. The right key opens doors you didn't know existed. The spacing effect shows that distributed practice leads to better long-term retention than massed practice. Studying material in shorter sessions spread over time produces stronger, more durable memories than cramming everything into one long session. This occurs partly because the process of retrieving information from memory strengthens it, and spacing creates more retrieval opportunities. Additionally, recent research suggests that sleep between practice sessions contributes significantly to the spacing effect. Each time you sleep after learning, your brain consolidates that information a bit more. Multiple sleep periods between practice sessions allow progressive strengthening of memories through repeated offline processing. Your subconscious benefits from time, from spacing, from the rhythm of learning and forgetting and relearning. Patience, it turns out, is crucial to embedding knowledge deeply into the mind. Traumatic memories can be stored differently than ordinary memories. Extremely stressful experiences can create particularly vivid, persistent, and intrusive memories. The amygdala's hyperactivity during trauma can impair the hippocampus's ability to properly organize the memory within a narrative framework. As a result, traumatic memories may exist more as sensory fragments and emotional responses than as coherent stories, leading to flashbacks that feel as if the event is happening again. Research from 2025 shows these memories often involve pathways connected to the amygdala, creating strong automatic responses that bypass conscious control. Therapeutic approaches that help integrate traumatic memories into narrative context can reduce their fragmentary quality. The subconscious holds trauma carefully, sometimes too carefully, until conscious processing can safely integrate what happened. Your subconscious processes social information constantly. The default mode network, which activates during rest, is particularly involved in social cognition, thinking about yourself and others, considering different perspectives, and navigating social relationships. When your mind wanders, it often wanders to social themes, replaying conversations, imagining future interactions, worrying about what someone thinks of you, or simply daydreaming about people you care about. This constant background processing helps you build and maintain your understanding of the social world. Research from 2025 confirms that disruptions in default mode network connectivity are associated with various social and psychological difficulties, including autism spectrum conditions and mood disorders. Your subconscious is always working to make sense of the complex web of relationships and social meanings that surround you, even when you're not consciously thinking about them. Intuition may be the subconscious recognizing patterns faster than conscious thought can articulate. When you have a gut feeling about a situation or suddenly know the answer to a problem without being able to explain how, your subconscious has likely detected patterns based on accumulated experience. This implicit knowledge guides decision-making even when you can't consciously access the reasons. Research on expert decision-makers, from chess grandmasters to experienced firefighters, shows they often make correct, rapid decisions based on intuition before they can consciously analyze the situation. Their subconscious has absorbed countless patterns through experience, allowing instant recognition of meaningful configurations. Your intuitions are not random or mystical, but emerge from the vast library of implicit learning your brain has accumulated over time. Sometimes the subconscious sees what consciousness has not yet grasped. Neurons that fire together wire together. This principle, first proposed by Canadian psychologist Donald Hebb in the mid-20th century, describes how memories are physically encoded in the brain. When you have an experience, specific patterns of neurons fire in synchrony. If that pattern repeats, especially during sleep when the hippocampus replays recent experiences, the connections between those neurons strengthen. Over time, these strengthened connections become the physical substrate of memory. Modern neuroscience research from 2025 shows that sleep-dependent replay involves precise coupling between hippocampal, sharp wave ripples, and cortical oscillations, facilitating the transfer of memory representations from temporary to permanent storage. Each memory is not stored in a single cell, but distributed across networks of connected neurons. Your subconscious continuously sculpts the architecture of your brain, one connection at a time, building the neural landscape of who you are. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of neurons working in silence, hippocampus storing, amygdala feeling, cortex thinking, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You're a complete system, processing, remembering, dreaming, all happening beneath awareness. Now we continue. Habits are memories stored as automatic behavioral sequences. When you first learn to drive, every action requires conscious attention, checking mirrors, adjusting speed, steering smoothly. With repetition, these sequences transfer to the basal ganglia, subcortical structures involved in procedural memory. Eventually, you can drive familiar routes while your conscious mind thinks about something else entirely. This automaticity is efficient, but also explains why habits can be difficult to change. The neural pathways supporting habitual behavior become deeply grooved through repetition, and conscious intention alone often isn't enough to override them. Effective habit change usually requires creating new environmental cues or triggers that activate alternative behavioral sequences. Your subconscious runs most of your daily routine, freeing conscious attention for novel challenges. Your brain absorbs patterns automatically, without instruction. In experiments where people are exposed to strings of letters following complex, made-up rules, they later recognize which new strings follow the same pattern, even though they can't explain why. The mind detects structure and experience silently. This automatic pattern recognition allows humans and other animals to extract regularities from their environment without explicit teaching. Language acquisition in children demonstrates this beautifully. The child's mind detects patterns in speech long before grammar can be explained. Much of what you know about the world was learned this way, absorbed quietly beneath the surface. Dreams may serve to integrate memories and emotions. During REM sleep, when most vivid dreaming occurs, the brain shows activity patterns similar to waking, but the chemistry is different. The neurotransmitter norepinephrine, associated with stress and arousal, is largely absent during REM. This unique state may allow the brain to reprocess emotional memories in a less intense context, potentially helping to resolve or regulate difficult emotions. Some theories suggest dreams create novel associations between recent experiences and existing knowledge, facilitating creative insights and problem solving. While the exact function of dreams remains debated, most neuroscientists agree that the strange narratives you experience during sleep reflect the subconscious mind actively working on unfinished cognitive and emotional business. False memories can feel as real as accurate ones. In classic experiments, researchers successfully implant memories of events that never happened by repeatedly asking people to imagine or describe made-up childhood experiences. Over time, some participants come to genuinely remember these fictional events, complete with sensory details and emotional reactions. This occurs because memory retrieval involves reconstruction, and imagination uses similar brain systems as memory. The more you imagine something, the more it can feel like something you actually experienced. False memories demonstrate that confidence in a memory does not guarantee its accuracy. Your subconscious cannot always distinguish between what happened and what was vividly imagined or suggested. Memory is malleable, vulnerable, and shaped by belief as much as experience. Working memory, the ability to hold and manipulate information temporarily, is limited in capacity. Most people can hold roughly 3 to 5 items in working memory at once, though this varies with practice and the type of information. This fundamental limitation explains why you struggle to keep track of more than a few things simultaneously. However, you can expand effective capacity through a strategy called chunking, grouping individual items into meaningful units. The letter sequence CIAFBINASA is difficult to remember as 9 separate letters, but easy when chunked into 3 familiar acronyms. Your subconscious automatically chunks information based on patterns it recognizes, quietly expanding your limited conscious processing capacity. Alzheimer's disease progressively damages memory systems, but not all types of memory are affected equally. The disease typically begins in the hippocampus and surrounding medial temporal lobe structures, which means episodic memory, the ability to form and retrieve personal experiences, is usually impaired first. People in early stages might forget recent conversations or appointments, but still remember events from decades ago. As the disease progresses, semantic memory, general knowledge, also becomes affected. However, implicit procedural memories often remain relatively preserved until later stages. Someone might forget they ever learned to play piano but still be able to play familiar pieces. These differences reveal how distinct memory systems depend on different brain structures, and how the subconscious can maintain certain capabilities even as consciousness struggles. Stress hormones like cortisol have complex effects on memory. Moderate stress at the time of learning can enhance memory formation, helping you remember important or threatening situations. This makes evolutionary sense. Remembering dangers improves survival. However, chronic stress or extremely high cortisol levels impair hippocampal function and can actually damage hippocampal neurons over time. Research from 2025 shows that cortisol levels during different sleep stages influence which types of memories are consolidated. High cortisol during deep slow-wave sleep can interfere with consolidation of declarative memories, while the natural rise in cortisol during late-night REM-rich sleep may serve different functions. Your subconscious must balance the need to remember important emotional events with the risk of being overwhelmed by stress-related memories. The phenomenon of childhood amnesia means most people cannot remember events from before age 3 or 4. This is not because those early years lacked experiences, but because the brain systems necessary for forming enduring explicit memories were still developing. The hippocampus continues maturing through early childhood, and the prefrontal regions that support autobiographical narrative memory develop even later. Interestingly, research from 2025 emphasizes that early experiences still shape personality, attachment style, and implicit knowledge about the world, even though they don't form conscious memories. The earliest years of life are stored in your subconscious as patterns of relating and responding rather than as stories you can tell. Your very foundation exists in the realm beyond words. Attention acts as a gateway to memory. Information that receives conscious attention is much more likely to be encoded into long-term memory than information that goes unnoticed. This is why multitasking often leads to poor memory. When attention is divided, encoding suffers. The hippocampus and surrounding medial temporal lobe structures require input from attention systems to properly process and store new experiences. However, the subconscious still monitors unattended information to some degree. Your brain automatically notices personally relevant stimuli, like hearing your name in a crowded room even when you weren't consciously listening. This balance between selective conscious attention and broader subconscious monitoring helps you focus on what matters, while still remaining alert to important changes in your environment. Semantic memory, your knowledge of facts and concepts, gradually becomes independent of the hippocampus over time. When you first learn something new, retrieving that information depends heavily on hippocampal networks, but through a process called systems consolidation, which occurs largely during sleep, the memory representations gradually transfer to neocortical networks, especially in the temporal and frontal lobes. Eventually, well-consolidated semantic knowledge can be retrieved even if the hippocampus is damaged. This explains why people with amnesia can retain old knowledge and skills while being unable to form new memories. Your subconscious slowly migrates important information from temporary to permanent storage, ensuring that fundamental knowledge becomes deeply embedded, resistant to disruption, woven into the very fabric of your understanding. Musical memories often persist even when other memories fade. People with advanced Alzheimer's disease or other forms of dementia can sometimes sing along to familiar songs or play musical instruments, even when they can't remember recent events or recognize loved ones. Music appears to be processed and stored across multiple brain systems, including regions involved in motor control, emotion, and memory. This distributed processing may make musical memories more robust. Additionally, music often connects to emotional experiences, which are processed by the amygdala and tend to form strong memories. The subconscious holds onto melodies and rhythms with particular tenacity, perhaps because music has been part of human culture for thousands of years, deeply embedded in how our brains are structured. The mere exposure effect demonstrates that familiarity breeds preference at a subconscious level. When people are repeatedly exposed to stimuli, even subliminally, they tend to develop more positive attitudes toward those stimuli without consciously recognizing them. In classic studies, people shown images too briefly for conscious awareness later prefer those images when shown them again, alongside completely new ones, despite insisting they've never seen either before. This effect influences many real-world preferences, from the music you like to the brands you trust. Your subconscious keeps track of what you've encountered repeatedly and quietly shifts your preferences toward the familiar. This can be adaptive, suggesting that familiar things are probably safe, but it also means your preferences are shaped by forces you may not recognize. Prospective memory refers to remembering to perform intended actions in the future. This differs from retrospective memory, which recalls past events, remembering to take medication at a specific time, to send an email after lunch, or to stop at the store on the way home all require prospective memory. This type of memory involves setting a mental reminder that your subconscious monitors while you go about other activities. Sometimes you suddenly remember what you intended to do, seemingly out of nowhere. That's your subconscious timekeeping system alerting you. Prospective memory relies on prefrontal and parietal brain regions and tends to decline somewhat with age. External aids like alarms or written reminders help support this memory system when the internal monitoring becomes less reliable. Memory reconsolidation offers therapeutic opportunities because retrieved memories become temporarily unstable before being stored again. There's a window during which they can be modified or disrupted. Some experimental treatments for post-traumatic stress disorder involve recalling the traumatic memory and then administering medications that interfere with reconsolidation, potentially weakening the emotional intensity of the memory. Other approaches use psychological techniques to add new, non-threatening information during the reconsolidation window, changing the emotional associations. This research is still developing, but it suggests that memories are not permanent, unchangeable records. The subconscious can be guided to reshape its representations of the past, offering hope for relieving the burden of painful memories that persistently intrude into awareness. Your subconscious processes facial expressions and emotions automatically. Within milliseconds of seeing a face, your brain has already assessed emotional expression, familiarity, and trustworthiness, all before conscious awareness catches up. The amygdala responds to fearful faces even when they're presented too briefly for conscious perception. This automatic emotional processing prepares your body to respond appropriately to social situations without requiring slow, deliberate thought. Research from 2025 confirms that this implicit emotional processing involves direct pathways from sensory areas to the amygdala, bypassing the visual cortex entirely. These subcortical routes allow rapid responses to emotionally significant stimuli. Your subconscious reads the emotional landscape constantly, helping you navigate social interactions with an intuitive sense of safety, threat, or opportunity, all happening beneath the surface. You're still here with me, thoughts still flickering like candlelight. Just notice, don't judge, just notice where your mind is. We're exploring consciousness itself, the very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. Eyewitness testimony is surprisingly unreliable. People can be completely confident about memories of events they witnessed, yet those memories can contain significant errors. The subconscious fills in gaps, reconstructs scenes based on expectations, and incorporates information learned after the event. In famous studies, researchers showed people videos of car accidents and then asked leading questions that changed how they remembered what they saw. Simply changing one word in a question, from hit to smashed, made people remember the cars going faster and even report seeing broken glass that wasn't there. Legal systems have slowly begun recognizing that confident eyewitness memory does not equal accurate memory. The subconscious weaves perception, expectation, and suggestion into seamless narratives that feel real. Neurons continue to grow and form new connections throughout life, a process called neuroplasticity. The old belief that the adult brain is fixed and unchangeable has been replaced by understanding that experience continuously shapes brain structure. Learning creates new synaptic connections, practice strengthens existing ones, and disuse weakens pathways that are no longer needed. Even the hippocampus, once thought incapable of producing new neurons in adulthood, shows ongoing neurogenesis in a region called the dentate gyrus. This ability to change means your brain and memory systems are never truly finished. Every experience, every night of sleep, every memory formed or forgotten subtly reshapes the neural architecture. Your subconscious remains capable of growth and change throughout your entire life. Priming affects behavior without awareness. If you're subtly exposed to words related to aging, you might walk more slowly afterward. If you're shown images related to achievement, you might persist longer on difficult tasks. These effects occur without conscious recognition of the prime or its influence. The subconscious processes contextual information and adjusts behavior accordingly. Advertisers and marketers have long understood this, using subtle cues to influence purchasing decisions. While individual priming effects are usually small and temporary, they demonstrate how external information can shape thought and action through pathways that bypass conscious awareness. Your subconscious is constantly influenced by subtle signals in your environment, gently nudging you in directions you don't consciously choose. The testing effect shows that retrieving information from memory strengthens it more than simply reviewing the material again. When you try to remember something, even if you struggle, the effort of retrieval creates stronger, more accessible memory traces. This is why practice tests improve learning more than rereading notes. The act of bringing information from subconscious storage into conscious awareness reinforces the neural pathways. Interestingly, this works even for incorrect retrieval attempts. Trying and failing strengthens the eventual correct memory more than not trying at all. Your subconscious benefits from being challenged, from the effort of search and reconstruction. Active engagement with memory, even imperfect engagement, builds more durable knowledge than passive reception. Sleep deprivation increases emotional reactivity. Without adequate sleep, the connection between the prefrontal cortex and amygdala weakens, reducing top-down emotional regulation. The amygdala becomes hyperactive, responding more strongly to negative stimuli. This explains why exhaustion makes people more irritable, anxious, and prone to emotional outbursts. Your conscious control over subconscious emotional responses depends on sleep. Research shows that even a single night of sleep loss can impair emotional processing and increase stress reactivity. Chronic sleep deprivation may contribute to mood disorders like anxiety and depression by persistently disrupting the balance between emotional brain regions. The subconscious emotional systems require rest to function properly. Without sleep, emotional memories intensify and regulation weakens. Implicit biases can be measured through reaction time tests. The implicit association test asks people to quickly categorize words and images, measuring how easily different concepts are associated. Someone might consciously endorse equality, but show faster reaction times when pairing negative words with certain groups, revealing automatic associations that contradict conscious beliefs. These tests remain somewhat controversial, but they demonstrate that explicit attitudes don't always match implicit ones. The subconscious absorbs associations from culture, media, and experience automatically. Becoming aware of implicit biases is the first step toward change, though research shows that modifying deeply ingrained automatic associations requires sustained effort and exposure to counter-stereotypical examples. The work happens gradually, beneath conscious awareness. The generation effect refers to the finding that information you generate yourself is remembered better than information you passively receive. If you try to answer a question before being told the answer, you're more likely to remember it later, even if your initial guess was wrong. If you write notes in your own words rather than copying verbatim, you retain more. This occurs because generation involves deeper, more elaborate processing. Your brain actively works with the material, creating richer memory representations. The subconscious encodes not just the content, but the process of creating it, providing multiple retrieval pathways. Passive learning leads to shallow encoding. Active generation creates stronger, more accessible memories. Nostalgia, that bittersweet longing for the past, serves psychological functions. Research shows that nostalgic reminiscence can improve mood, increase feelings of social connectedness, and provide a sense of continuity in one's life narrative. When people feel lonely or uncertain, they often turn to nostalgic memories, which typically feature close relationships and meaningful experiences. This isn't mere escapism. Nostalgia appears to help people cope with present difficulties by reminding them of enduring sources of meaning and connection. The subconscious selectively highlights positive aspects of past experiences, creating a repository of emotional comfort. These idealized memories may not be perfectly accurate, but they serve the present by providing psychological resources when needed. Mirror neurons fire both when you perform an action and when you observe someone else performing the same action. Discovered in monkeys and later found in humans, these neurons may contribute to understanding others' actions and intentions. When you watch someone smile, some of the same neural circuits activate as when you smile yourself. This neural mirroring might underlie empathy and social learning. By simulating observed actions internally, your brain can predict what others might do next or understand their goals. The subconscious constantly mirrors and simulates the mental states of people around you, helping you navigate the social world. Your sense of others is partly built from automatic internal simulations running beneath awareness. Flashbulb memories are vivid, detailed memories of significant events, like where you were during a major historical moment. People often feel absolutely certain about these memories, recalling specific details with clarity. Yet something curious emerges from research. These vivid memories feel more accurate without necessarily being so. Studies examining memories of major events found that people's recollections changed over time. Even though their confidence remained high, the emotional arousal associated with significant events enhances the feeling of memory vividness without improving accuracy. Your subconscious creates this sense of clarity and certainty, but confidence and truth are not always aligned. Let each breath guide you to realize time is yours, a separate stream that only you are living. While the vast universe continues to spin, expand, change, this second you're breathing, listening, is unique. Cherish the present moment, knowing that right now your time is unique in the universe. And we continue drifting. Your subconscious tracks statistical patterns automatically. When young children learn language, they absorb complex grammatical rules without explicit instruction by detecting regularities in speech patterns. Adults can also learn artificial grammars this way. The subconscious continuously extracts structure from experience, building models of how the world works. This statistical learning operates across many domains beyond language, helping you predict what will happen next based on past patterns. You often know something will happen before conscious thought catches up, not through magic, but through subconscious pattern recognition. Your brain is a prediction machine, constantly forecasting the future based on regularities it's quietly noticed. Stress can sometimes enhance memory formation. Emotionally arousing experiences trigger the release of stress hormones and neurotransmitters that enhance consolidation, particularly for the central, most emotionally salient aspects of the experience. This is why you vividly remember frightening or exciting moments. However, stress hormones can impair memory for peripheral details and may actually impair retrieval of information learned earlier. The relationship between stress and memory is complex. Following an inverted U pattern, moderate arousal enhances memory, but extreme stress can disrupt it. Your subconscious calibrates how to respond, sometimes prioritizing emotional intensity over complete accuracy. What mattered in the moment gets preserved, everything else may fade. The striatum, part of the basal ganglia, is essential for habit formation. When behaviors become habitual through repetition, control shifts from goal-directed systems involving the prefrontal cortex to habit systems involving the striatum. Habits are triggered by contextual cues and run automatically once initiated. This is why changing your environment can help break bad habits. The usual triggers are no longer present. The subconscious habit system is powerful but inflexible. It executes learned sequences efficiently, but doesn't easily adapt to new goals or circumstances. Understanding the neuroscience of habits helps explain why willpower alone often fails and why environmental design matters. Metacognition refers to thinking about thinking, your ability to monitor and evaluate your own cognitive processes. When you have a feeling of knowing, confident you know something, even though you can't currently recall it, that's metacognition at work. Your subconscious provides signals about the state of your own memory. These signals are usually helpful but not always accurate. The tip of the tongue phenomenon, where you're sure you know a word but can't produce it, demonstrates how metacognitive feelings can be strong yet incomplete. Your conscious mind receives reports from deeper processes, but these reports are summaries, not complete access to subconscious operations. Research from 2025 confirms that memory consolidation requires energy. During sleep, neurons activate gene transcription in mitochondria, the powerhouses of cells, increasing energy production to support the synthesis of proteins needed for memory storage. This coupling between neural activity and energy metabolism helps maintain brain plasticity. As people age, this coupling weakens, which may contribute to age-related memory difficulties. Enhancing this connection through various interventions might improve memory and combat cognitive aging. Your subconscious doesn't just process information, it requires biological resources, energy, and cellular maintenance. Memory is physical, metabolic work happening while you sleep. The lateral prefrontal cortex helps with strategic retrieval of memories. When you try to remember something specific, this region coordinates the search process, generating and evaluating potential candidates. Damage to this area doesn't necessarily impair memory storage but makes effortful retrieval difficult. People might recognize information when presented with it, but struggle to search memory independently. This shows that storage and retrieval are separate processes. Your subconscious holds the memories, but conscious retrieval requires additional machinery to locate and bring forward the right information. Sometimes memories are there, intact, but the search system fails. Social memories appear to use specialized brain networks. Remembering interactions with people, particularly close relationships, activates regions including the medial prefrontal cortex and posterior cingulate cortex, key nodes in the default mode network. These are the same regions involved in thinking about mental states, yours and others. The neural systems supporting social cognition and autobiographical memory overlap extensively. This makes sense. Much of your personal history involves other people. Your subconscious stores memories of relationships within networks designed for navigating the social world. Memory and social understanding are intertwined, both rooted in your sense of self in relation to others. Confabulation occurs when memory gaps are unconsciously filled with fabricated information presented as real memories. This is not deliberate lying, but a failure of memory monitoring. People with certain types of brain damage, particularly to frontal regions, may confabulate extensively, creating elaborate false narratives without realizing they're incorrect. Healthy people confabulate too, on a smaller scale. When memory is uncertain, the subconscious prefers coherent narratives and will generate plausible details to fill gaps. This demonstrates that your brain prioritizes making sense over strict accuracy. Memory serves understanding and meaning more than historical precision. The concept of engrams refers to physical memory traces in the brain. Modern research has identified specific populations of neurons that become active during learning and are reactivated during memory retrieval. These neurons form the engram, the neural representation of the memory. Recent techniques allow researchers to label engram neurons and then artificially activate them, effectively triggering a specific memory. This demonstrates that memories have a physical substrate that can be precisely identified and manipulated. Your subconscious memories exist as specific patterns of connectivity within neural networks, written in the language of synaptic strength and neural firing. The hindsight bias makes past events seem more predictable than they actually were. After something happens, you often feel you knew it all along, even if you didn't. This cognitive bias affects memory for your own prior beliefs and predictions. Your subconscious revises history to make it more coherent, integrating current knowledge into past recollections. While this creates a comforting sense of understanding, it can impair learning from experience. If you believe you predicted outcomes correctly, you may miss opportunities to improve judgment. Your memory of the past is colored by knowledge of how things turned out. Imagination and memory involve overlapping brain systems. When you vividly imagine a future scenario, you activate many of the same regions that activate when remembering a past event, including the hippocampus and cortical networks. This overlap explains why imagining future events helps you prepare for them. Your brain treats mental simulation similarly to actual experience. It also explains why imagining events repeatedly can create false memories. The subconscious doesn't always distinguish between what was experienced and what was vividly imagined. Memory and imagination are sister processes, both reconstructing scenes from fragments, both blending perception with creation. Emotional regulation strategies influence memory. If you reappraise a negative situation, thinking about it differently to reduce negative emotions, you change how that experience is stored in memory. Research shows that cognitive reappraisal during or shortly after an emotional event can reduce the emotional intensity of subsequent memories. Your prefrontal cortex modulates amygdala activity, shaping how emotional memories are encoded. This means the stories you tell yourself about experiences actually reshape the memories themselves. The subconscious stores not just what happened, but how you interpreted and responded to it. Meaning and emotion are woven together in memory's fabric. The concept of memory schemas refers to organized knowledge structures that guide encoding and retrieval. When new information fits existing schemas, it's easier to remember. When information violates expectations, it may be remembered particularly well because it stands out, or it may be distorted to fit the schema. Your subconscious uses schemas to make sense of experience, but this can introduce systematic biases. You remember what fits your understanding and what dramatically violates it, while moderately inconsistent information may be normalized or forgotten. Memory is constructive, shaped by frameworks built from past experience. Sleep spindles, brief bursts of brain activity during non-REM sleep, play an important role in memory consolidation. These oscillations, typically lasting a second or two, occur in the thalamus and spread across the cortex. Research shows that the number and timing of sleep spindles correlates with memory performance. They appear to facilitate the transfer of information from hippocampus to cortex, helping to stabilize memories. Recent 2025 research demonstrates that coupling between spindles, slow waves, and hippocampal ripples is particularly important. Your subconscious orchestrates this complex neural symphony during sleep, each element coordinating with others to build lasting memory. Motivation influences what you remember. You're more likely to encode and retain information relevant to your current goals and interests. This makes evolutionary sense. Organisms that prioritize remembering useful information have survival advantages. Research shows that reward-related brain regions, including parts of the striatum and prefrontal cortex, interact with memory systems to enhance encoding of motivationally significant events. Your subconscious filters experience through the lens of relevance, giving preferential treatment to information that matters to your goals. Not everything receives equal processing. What you care about becomes what you remember. The amygdala and hippocampus work together during emotional memory formation. The amygdala, responding to emotional significance, modulates hippocampal processing, enhancing the encoding of emotionally arousing experiences. This interaction explains why emotional events create stronger memories. However, the two structures can also work somewhat independently. Someone with amygdala damage might remember facts about an emotional event, but lack the emotional feeling associated with it. Someone with hippocampal damage might feel emotional responses without remembering the original context. Your subconscious separates factual memory from emotional memory, storing different aspects of experience in different systems. Source memory refers to remembering where or how you learned information. You might remember a fact but forget whether you read it, heard it, or thought it yourself. Source memory depends on the frontal lobes and is particularly vulnerable to aging and brain injury. This is why older adults sometimes struggle to remember whether they actually told someone something or only thought about doing so. Your subconscious stores content more reliably than context. But what is more durable than the where and when? As memory ages, context fades while core content may remain. Different emotions create different patterns of memory. Happiness tends to broaden attention, leading to better memory for general context and relationships between elements. Anxiety narrows attention, leading to better memory for central threatening details but poorer memory for peripheral information. Sadness promotes analytical, detail-oriented processing. The subconscious tailors memory encoding to emotional state, presumably because different situations require different types of information. Your current feelings don't just color experience, they shape what you'll remember about it. Emotion is not separate from memory, but integral to how memories form and what they contain. Memory for emotional faces differs from memory for neutral faces. The amygdala enhances encoding of emotional expressions, particularly fearful ones, which signal potential threat. You typically recognize fearful or angry faces you've seen before more accurately than neutral or happy ones. This bias exists even when faces are presented very briefly, or when attention is divided. Your subconscious prioritizes detecting and remembering potential threats, an adaptation that served survival in ancestral environments. The emotional memory system operates automatically, scanning the social environment for signs of danger or opportunity, storing meaningful patterns for future reference. Neuroimaging studies can decode memory content. Using patterns of brain activity, researchers can determine which of several memories someone is currently recalling, sometimes even identifying specific details. This demonstrates that different memories have unique neural signatures. While far from reading minds in a comprehensive sense, these techniques show that memory is encoded in distributed but consistent patterns of neural activity. Your subconscious stores each experience as a specific constellation of active neurons. Modern technology can begin to glimpse these patterns, revealing the physical basis of subjective experience. The self-reference effect describes enhanced memory for information related to yourself. When you process information by relating it to your own experiences, knowledge, or characteristics, you remember it better than if you process it in other ways. For example, judging whether an adjective describes you leads to better memory for that word than judging whether it's written in uppercase letters. This occurs because self-related processing engages the medial prefrontal cortex and activates rich, elaborate networks of associations. Your subconscious prioritizes information connected to your sense of self, the organizing principle around which other knowledge arranges itself. Memory undergoes gradual changes over time even without retrieval. Memories naturally decay, particularly if they're not occasionally reactivated, but memories can also be influenced by other experiences you have later. New learning can retroactively interfere with older memories, particularly if the information is similar. Your subconscious continues processing and organizing memories even during periods when you're not consciously thinking about them. The past is not fixed in memory, but continues evolving, shaped by present experiences, gradually drifting and transforming in the deep currents of the mind. Arousal at encoding predicts memory strength, but arousal at retrieval can sometimes impair it. When you're trying to remember something during a stressful situation, like taking a test, high stress levels can interfere with retrieval, even though that same level of arousal might have enhanced encoding. This is why staying calm during exams often helps performance. Your subconscious memory systems function best within an optimal range of arousal. Too little, and encoding is shallow; too much, and retrieval becomes difficult. The Goldilocks principle applies: not too much, not too little, but just right. Memory involves both synaptic changes and systems-level reorganization. At the microscopic level, memories strengthen through chemical changes at synapses between neurons. At a larger scale, memory consolidation involves redistribution of representations across brain regions, from hippocampus to cortex. Both levels are essential. Synaptic plasticity provides the basic mechanism of storage, while systems consolidation provides organization and integration. Your subconscious operates across multiple scales simultaneously, from molecules to neural networks to whole brain systems, each level contributing to the architecture of memory. Recent research from 2025 demonstrates that the default mode network represents not just your current mental state, but also contains an internal model of the brain's own activity. The posterior regions of this network appear to simulate the brain's processing, creating a kind of meta-awareness. This internal model may be crucial for self-reflection, the ability to think about your own thinking. Your subconscious contains representations not just of the external world but of itself, a mind aware of its own existence, though most of this self-modeling occurs beneath conscious awareness. You might be feeling tired now. That's perfectly fine. Breathe slowly, feel the cycles. Thoughts arise, thoughts dissolve, memories form, memories fade. The mind breathes in experience, breathes out understanding. All are circles, cycles, endless rhythms. Like your breath, inhale, exhale, inhale, exhale, a small cycle within the vast universe. You're also part of that eternal movement. You don't need to hold on to anything. Let everything unfold in its perfect order, like waves silently rising and falling, unhurried, unresisting, simply existing. We're almost there now. Memory connects you to others across time. When you remember someone who is no longer present, that memory keeps their influence alive within you. Stories passed down through generations carry memories beyond individual lifetimes. Your subconscious holds not just your own experiences but echoes of others, threads of connection spanning years and distances. Memory is how love persists, how wisdom transfers, how humanity maintains continuity. Each memory is a bridge across the void. The brain reorganizes memories during offline states, not just sleep but quiet rest while awake. When you pause and let your mind wander, the default mode network activates, and memory consolidation processes can occur. Brief breaks during learning improve retention. Your subconscious needs moments of disengagement from external tasks to process and integrate what you've experienced. Rest is not wasted time, but essential time. Some memories feel like they belong to someone else, especially very old ones from early childhood. The person you were decades ago can seem almost like a stranger. This is partly because you've changed and partly because old memories lack the rich contextual detail of recent ones. Your subconscious maintains continuity across these changes, threading identity through transformation. You're both the same person and perpetually becoming new. The feeling of familiarity arises from the brain's recognition system assessing how easily information is processed. When something feels familiar, it's being processed fluently, quickly, easily. This fluency gets interpreted as previous exposure. Sometimes this system errs, creating false feelings of familiarity, but mostly it works, quietly informing you what you've encountered before. Your subconscious tracks experience silently, signaling recognition through feeling rather than explicit remembering. Memory serves the future more than it preserves the past. The brain uses past experiences to predict and prepare for what's coming. Episodic memory, with its rich sensory detail, allows mental simulation of potential future scenarios. Your subconscious draws on memory not to dwell on what was, but to navigate what will be. The past is a library for building tomorrow. The position you sleep in may affect how well your brain clears waste products. Research in animal models has suggested that side sleeping might facilitate the brain's waste clearance systems, which remove cellular debris during sleep. Whether this significantly affects human memory remains an area of ongoing study. Your subconscious does its work regardless of position, but physical factors may influence the efficiency of this nightly maintenance. How you rest your body might matter more than you realize, though the sleeping mind continues its essential work in any comfortable position. Music can trigger powerful involuntary memories. A song you haven't heard in years suddenly plays, and you're transported back to a specific time and place, feeling emotions you'd forgotten. This happens because music is processed by multiple brain systems simultaneously, creating rich, multi-layered memory traces. Your subconscious archives melodies with emotional depth, waiting for the right notes to unlock doors you didn't know were closed. The mere thought of sleep can begin to activate sleep-related brain changes. As you lie down and close your eyes, knowing sleep is near, your brain starts transitioning even before you lose consciousness. Your subconscious responds to context and expectation, preparing for the transformation from waking awareness to sleep's deeper processing. Rest begins before sleep arrives. Memory researchers distinguish between remembering and knowing. Remembering involves recollecting specific details and mentally traveling back to the original experience. Knowing is recognizing information as familiar without contextual details. Both are forms of memory, but they feel different and rely on somewhat different brain systems. Your subconscious stores memories with varying degrees of richness, from vivid recollection to faint recognition. The sense system connects directly to memory structures in unusual ways. Smells bypass the thalamus and connect directly to the olfactory cortex, which has strong connections to the amygdala and hippocampus. This may explain why odors trigger particularly vivid, emotional memories. A scent can instantly transport you to another time. Your subconscious links smell with emotion and memory in ancient, powerful ways. Collective memory refers to how groups share and maintain memories of historical events. Societies remember through stories, rituals, monuments, and shared narratives. These collective memories shape identity and culture. Your individual subconscious is embedded within larger systems of shared meaning and memory. What you remember is influenced by what your community remembers, weaving personal and collective history together. Memory loss doesn't erase the person. Even when explicit memory fades, implicit knowledge, emotional reactions, and procedural skills can remain. The core of personality often persists even through severe memory impairment. Your subconscious holds many forms of knowledge, only some of which depend on conscious recollection. Identity lives in many layers. Your brain creates entire worlds while you sleep. Every night, during REM sleep, your mind constructs vivid experiences from memory fragments, emotions, and abstract patterns. Characters appear, conversations unfold, landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with sights, sounds, and even physical sensations, yet they vanish upon waking, like morning mist. The sleeping brain is not resting but creating. Forgiveness may involve changing the emotional associations attached to memories of harm. The event remains remembered, but its emotional grip loosens. Research suggests this requires integrating the painful memory into a broader narrative context and engaging regulatory brain regions. Your subconscious can gradually release emotional charges through repeated processing and reframing, though complete transformation takes time. The experience of time is constructed by memory. Your sense of how long something lasted or how long ago it occurred depends on memory processes rather than direct time perception. When memories are rich and detailed, time seems to have passed slowly. When memories are sparse, time seems to have flown. Your subconscious creates your experience of duration and distance in time. Memory and identity are inseparable. Your sense of who you are emerges from the continuity of remembered experience across time. Without memory, the self fractures into disconnected moments. Your subconscious maintains this thread of identity, weaving past into present into future, creating the story of you. Memory is the foundation of selfhood. Some memories are never fully accessible to consciousness. Implicit learning during infancy, emotional conditioning you don't recognize, subtle patterns absorbed without awareness, all live in your subconscious, shaping thought and behavior from the shadows. Not everything that influences you can be remembered explicitly. Much remains hidden, operating beneath the surface. The boundary between memory and imagination blurs in interesting ways. When you imagine meeting someone new, you draw on memories of past social interactions. When you remember the past, you inevitably add imaginative details to fill gaps. Memory and imagination are partners, both constructing mental representations from fragments. Your subconscious blends what was with what might be. Shared experiences create shared memories that bond people together. When you and others go through something significant together, remembering it later strengthens social connections. Reminiscing about shared memories maintains relationships across distance and time. Your subconscious stores not just events but relationships, connections woven through common experience. The process of memory consolidation is delicate and complex, easily disrupted by various factors but remarkably resilient when conditions are right. Sleep, emotion, attention, repetition, meaning, all influence what becomes permanently stored. Your subconscious carefully selects what matters, building the architecture of a long-term memory, one connection at a time. Memory is reconstructive, creative, adaptive, and deeply personal. No two people remember the same event identically. Your subconscious filters experience through your unique history, attention, emotions, and interpretations. Each memory is yours alone, colored by your particular mind. Memory makes you individual. The default mode network, active when your mind wanders, connects past, present, and future. It draws on memory, evaluates the current situation, and imagines possibilities ahead. This network represents your internal mental space, the realm where your subconscious self exists. Here, beyond external demands, your deepest sense of self resides. Memory is imperfect but meaningful. It serves understanding rather than perfect accuracy. It connects you to your history, to others, to your sense of meaning. Your subconscious curates experience not to create an archive, but to build a life. Memory is how you become who you are. The subconscious never stops. Even now, as you listen, it processes, stores, connects, creates. It works while you sleep, while you rest, while you focus elsewhere. Most of what your brain does happens beneath awareness. The subconscious is the silent majority of your mental life. Memory connects all moments of your life into a continuous stream, creating the experience of being a single person persisting through time. Without memory, there would be no yesterday, no anticipation of tomorrow, no narrative self. Your subconscious builds this continuity quietly, constantly, weaving existence into meaning. Memory is consciousness extended through time. And so, our quiet journey through the hidden chambers of memory comes to a gentle close. We've traveled from the default mode network humming beneath awareness to the hippocampus replaying yesterday's experiences while you sleep, discovering along the way that consciousness is only the visible surface of a vast subconscious sea. From the amygdala storing emotional patterns you never chose to learn, to the slow dissolution of childhood memories into feeling rather than story, we've glimpsed how memory is both profoundly personal and universally human. Memory reminds us that the mind is layered, deep, mostly hidden from itself. Much of the fascinating work happens in silence, beneath awareness, in the default rhythms of neurons firing while you rest. These subconscious systems teach us patience with ourselves. Without the hidden processing during sleep, without the quiet work of consolidation, learning would fail. By pausing to notice the mind's depths, we glimpse how little of thought is truly conscious. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about consciousness itself, yours, mine, everyone listening, all awareness everywhere, perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought. Prepare for deep sleep, no boundaries left, only peace. If this thoughtful exploration of the mind made you feel less alone, whisper it forward to someone awake tonight. It may bring comfort to one more wandering consciousness. One quiet share, one peaceful night at a time. But there's no need to do anything now, nothing at all. You've traveled far tonight, deeper than most journeys take you. You can allow these thoughts of memory and mind to fade now, like ripples on water eventually smoothing to stillness, leaving only the peaceful calm behind. Let your breathing deepen, let your body feel heavier, as if sinking gently into the earth itself. If sleep comes, let it carry you like a leaf floating downstream, smoothly, inevitably, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, memory will still be there. Your subconscious will still be working beneath awareness. But tonight belongs to stillness. Rest well, curious mind. And remember, most of who you are lives in the depths you cannot see, working quietly, patiently, wisely. Dream deeper with bedtime science. Good night.